Hello everyone, welcome to Learn ReactJS for Frontend Development by CodeChef. In today's lesson, we'll have a look at state and props in React, an important concept which will form the foundation of almost every React component you will write. These concepts will decide how your information is passed, stored, and updated across your React application. Many common React issues like unexpected UI behavior or unnecessary re-rendering can be traced back to misunderstanding around these concepts. By the end of this lesson, you will understand the difference between props and state, how data flows between components, and how to use them correctly in React. So let's begin. So let us understand one of the most important concepts in React, the difference between props and state. Both are used to handle data in React components, but they serve very different purposes. Knowing when to use props and knowing when to use state is critical for building clean, predictable, and scalable React applications. React applications are built entirely around data. Every piece of information you display on the screen comes from either props or state. If data is handled incorrectly, it often leads to bugs, unexpected UI behavior, or components that are hard to reuse. That's why understanding how props and state work is foundational to writing good React code. Let's start with props. Props are used to pass data from a parent component to a child component. They are similar to function arguments. The child component receives them and uses them, but does not modify them. An important rule to remember is that props are read-only. A component should never change the prop it receives. Here's a common use case for props. A parent component sends different values such as name and role to a reusable child component. The same component is reused multiple times, but it displays different data based on the props passed to it. This makes props ideal for reusability and one-way data flow where data moves from parent to child. Now let us talk about state. State is used to store data inside a component. Unlike props, state is meant to change over time. Whenever the state changes, React automatically re-renders the component so that the UI stays in sync with the data. State is commonly used for things like user input, counters, toggles, or any value that changes during interaction. A simple example of a state is like a button. When we use the useState hook to initialize a value, such as a like count, when the user clicks the button, the state is updated. Once the state updates, React re-renders this component and the new value appears on the screen automatically. This is the core idea behind interactive user interfaces in React. Now let us clearly compare props and state. Props are controlled by the parent component, while state is controlled by the component itself. Props do not change inside the component, but state is designed to change. A simple way to think about it is, if the component owns the data and it changes, use state. If the data comes from outside and should not be modified, use props. You should use props when the data comes from a parent component, is only needed for a display, and helps make a component reusable. Props allow you to create flexible components that behave differently based on the data they receive. So when should you use state? You should use state when the data changes over time, is affected by user actions, and needs to be managed by the component itself. State is what allows React components to respond dynamically to user interactions. To summarize this, props are used to pass down data from parent to child. State is used to manage data that changes within a component. The key decision always comes down to data ownership and whether the data changes. So let us look at dynamic key generation in React. In this problem, we are building a simple guest list app where the users can see a list of guests and remove them by clicking the remove button. At first glance, the app works. Guests are displayed correctly and clicking the remove button deletes an item from the list. However, there is an important issue hidden in the code. Let's look at how the list is rendered here. We are mapping over the guests array, and for each guest we are using the array index as the key. Using array indexes as keys is problematic in React, especially when items are added or removed. This is because indexes change when the list changes. When a guest is removed, React may incorrectly match components, leading to input showing the wrong values, unexpected UI behavior, and inefficient re-renders. React relies on keys to identify elements uniquely, and indexes fail to provide that guarantee when the list is dynamic. So why does this happen? React uses keys to track items which have changed, been added or been removed. When we use the index as a key, removing one item shifts all the index after it. React thinks elements have only moved, not changed. The internal component state can get mixed up. This is why React strongly recommends not using indexes as keys when the list can change. Now let us look at how we can solve this particular problem. To fix this issue, each guest needs a stable, unique identifier that does not change when the list changes. Instead of storing guests as plain string, we update the data structure to store each guest as an object with an ID and a name. We generate the ID using crypto.randomuid method, which guarantees a unique value for every guest. Now, when rendering the list, we use guest.id as the key, and this key remains the same even if items are added or removed. When removing a guest, instead of using splice and indexes, we use filter. We remove the guest whose ID matches, and this approach is cleaner and avoids mutation issues. As a result, React can correctly track each list item, and the UI behaves predictably, along with the inputs retaining the correct values. Now the key lesson here is that when rendering dynamic lists in React, never use array indexes as keys and always use a unique and stable identifier. If your data does not already have an ID, generate one using tools like crypto.randomuid. This ensures correct rendering, better performance and predictable UI behavior. Now in this particular problem, we are going to understand an important React concept called lifting state up. You use this pattern when multiple components need to share the same piece of changing data. Now let us look at the initial version of the code over here. We have a text input component that uses useState to manage its own text value. Inside the app component, we render two instances of this text input. At first, this might seem correct. Each input works independently, and typing inside one updates its value. However, there is one problem. If we type into one input box, the other input does not update. Each input maintains its own separate state, so the two components are completely independent and out of sync. This happens because state is not shared between the components. But why is this an issue? In this scenario, both input fields are meant to reflect the same value. But since each text input component manages its own useState, React treats them as unrelated pieces of data. When multiple components need to display or modify the same data, keeping separate state inside each component leads to inconsistent behavior. So let us look at the solution. Now to fix this, we will apply the concept of lifting state up. The idea is simple. We identify the shared data, move that state to the closest common parent, and pass the state and update the logic down as props. In this case, the closest common parent of both text input components is the app component. Now first, we will remove the useState from the text input component. Now instead, text input will receive two props. Value, which is the current text, and onChange, which is a function to update the text. This makes text input a control component, meaning it no longer manages its own state. The app component now holds the shared state using useState. It also defines a handler function handleTextChange, which updates the state whenever the user types into either input. So let's see how the data flows step by step. When you type into either input field, the onChange event fires. The text input component calls the onChange function it received as a prop. That function updates the state in the app component. Since the state in app changes, React re-renders the app component. The updated value is passed back down to both text input components through props. As a result, both input fields always display the same value and stay perfectly in sync. The key idea to remember is this. When multiple components need to reflect the same changing data, lift the state up to their closest common ancestor. That parent component becomes a single source of truth, and it passes down the data and updates functions down to its children using props. This pattern is essential for building predictable and well-structured React applications. So that's a wrap up on how to use props and state in React. To really understand this concept, make sure to head over to the CodeChef platform and try out the practice problems yourself. That's where the real learning happens. So that was it for this lesson, and I will see you in the next one. Thank you.